All right, 1.1, day number 4, intro to relations and continued Venn practice. We're not going to do a whole lot with Venn diagrams other than just practice a little bit more. You're probably wondering why I have these 4 cloudy blotches of whatever they are on the board. What I'm going to do is take you through an abstract version of what a relation is. It's a relationship between what we know to be the domain of a function and its relationship to some number in a range. What's another word we use for domain? It starts with an I. Ends in input. Input, yeah, and range is the same as what? Some kind of output, right? And what happens in between the two we call, in some cases, a function. But it's not always a function, and you're probably thinking, vertical line test. Right? Doesn't the vertical line test confirm whether or not something's a function? Oh. Okay, well, I guess we'll get there then. So let's say I have some number in the input of this relationship. Let's say that number is 1, and 1 maps, right? These numbers map from the domain to the range. Let's say it maps to 5. Okay, and 3, I'm going to have that map to, what number do we want that to map to? 17, okay. And negative 11 halves maps over here to what? How about pi? It's just weird, right? Don't mess with that. That's a relationship, right? That's what we call a relation. That's actually also a function because it's 1 to 1. Well, what would happen? What would make this become something other than a function, right? What happens? Well, the vertical line test fails. So let's come up with an example of a relation that is not a function. Okay, so 1 went to, what was it, 3? Oh, 5. 3 went to, say again, 17. And negative 11 halves went to pi. How would I make this relation no longer be a function? Well, I'd have to confuse the operator, right? The operator thinks if I plug in a 3, I'd better get a 17. So how could I confuse the operator? I could make 3 have 2 separate outputs. Right? So let's say 3 also maps to the number, I don't know, 17 thirds. Now the function is confused. Which one do I map to? It's kind of like a type A person. It's like, no, it's Tuesday. I vacuum on Tuesdays. No. I can't dust the living room on Tuesday. I only vacuum on Tuesdays. 3 can only map to 17. Now I'm confused. This isn't a function. Function can't output 2 separate outputs for the same input. This microphone's creeping up on me. Okay, so let's talk about that. Let's look at an example of a relation. Okay, so a relation is a set of points in a plane, right? An input that gives outputs. A relation, that all it needs to happen is that there are inputs and there are outputs. Doesn't matter how they're related. A function is a set of 1-to-1 points in a plane. So let's talk about that. All blank are blank. Oh, well, what the heck? We could. What is the larger set here? Functions or relations? Relations are the larger set. So a relation in Venn diagram form holds within it all functions. So in this case, all functions are relations, but not all relations are functions. Did I get that right? Let's see. Yeah, we're good. All functions are relations, but not all relations are functions. I'll get it someday here, guys. Okay, so let's look at an example. Here, what we know, set notation, interval notation, and I'm throwing a new one in called roster notation, but it's not as important as these two. Set notation and interval notation are the important ones. So let's graph this thing, right? I'd like for you and a neighbor to graph this set, and we'll come back and we'll look and just. Does your sketch look similar to that? Right? So I've got the points given in roster notation as 0, 3, 1, 3, 2, 3, 3, 3, 4, 3. Technically speaking, based on that, my set should only look like that, based on that notation. Based on this notation, how would this notation, this set builder notation, make that graph look different? This says all points, x, y, such that x is less than or equal to 4 and y always equals 3. Could x equal, say, 3.9? Sure. Could it equal, negative 2.5? Sure. Can it exceed 4? Can it equal 4? Yes. So this set notation here, set builder notation, is supposed to represent the same set. However, when sketched, it should look like that. Right? Y is always equal to 3, and x is less than or equal to 4. Boom, I got a horizontal line starting at 4 and heading off to the left forever. Is that a function? How do I know it's a function?
Because it passes the vertical line.
Good. Any vertical line that I sketch, it only crosses the graph once. Right? Before, when I said 3 could map to 17 or 17/3, that would require there to be one point directly above another, vertical line test failure. Right? So this does pass the vertical line test, and therefore is a function. Is it a relation? Yes, it is, because all functions are also relations. So therefore, this is both a relation or a function. If I ask you if something's a relation or a function, it's not a function, it's a relation. And if you ever say it's not a relation, then you probably failed it. It's always a relation. There's always a relationship there. Points mapping to other points. It's just whether or not is it a function. Great. So let's sketch a couple funky relations based on some notation. Okay, this, read from left to right, would be H, the set H, equals all points such that y is equal to -2. Have I restricted x at all? No. So x can be any number, but y has to be -2. Relation? Don't say no. Relation? Yes. Function? Yes, it is both. Let's do the next one. This one's weird. R is the set of all points such that y is greater than 1, less than or equal to 3. Are there restrictions on x? No. X can be anything. Y is between 1 and 3. Am I done? No. What do I do now? Shading. Shading. It's all points such that y is between 1 and 3, equaling 3 as well. Would that be a relation? Yes, your immediate answer is yes. Function? No, it doesn't pass the vertical line test. Therefore, this is relation only. In pairs, try this one.